Hey guys, welcome to this advanced Python course. My name is Patrick and I create free tutorials about Python and machine learning. In this course, I teach you all the advanced topics that bring your Python skills to the next level. So who is this course for? This course is aimed at an intermediate skill level. You should already have some basic Python knowledge. For example, if you just completed a beginner course and are looking for the next step, then this tutorial is perfect for you. And even if you are already in the intermediate level, you can benefit from this because I share some helpful tips along the way and we really go into detail of all the different topics. So here's an overview of what we will cover today. The course is split into 21 sections, and in my opinion, every experienced Python programmer should know about these topics. Alright, let's start. A list is a collection data type that is ordered, mutable, and it allows duplicate elements. So let's have a closer look at lists and what you can do with them. First of all, a list is created with square brackets, and within these brackets you put each element that you want separated by a comma. For example, let's put some strings in here. Banana, a list is a collection data type that is ordered, cherry, and it allows duplicate elements. So and an apple. And if we print this, then we see that all elements are printed. Now you can also create a new empty list with the list function. So my list2 equals list. And if we print this, then we see that this creates an empty list, and later on you can append items. And if we print this, then we see that all elements are printed. We can also create a new empty list with the list function. With the list function. Let's say banana in my list, colon, and say let's print yes, and else print no. Now if you run this, then we see that the banana is inside our list. So let's check if the lemon is no, yes, the apple else yes, So that's a very simple syntax to check if your index is inside your list. Now let's talk about some other useful methods that you can do with a list. First of all, if you want to check how many elements do you have inside your list, you can do that with the len method. And now if we print this, and we see that we have 3 elements inside our list. Now if we want to append items, we can do that by mylist.append, and now let's append a lemon. Now if we want to append items, we can do that by mylist.append, and now let's append a lemon. Variable and print it, and we see that now we got our apple back. And if we print our list, then we see that the apple is no longer in our list. Now we can also remove a specific element with the .remove method. For example, let's remove the cherry. Then we see that the cherry got removed. Now what happens if we specify an item that is not inside our list? For example, if we have a typo here, then we get a value error, x not in list, so be careful here. We can also remove all elements with the clear method. So now we have an empty list. Some more useful things that you can do is, for example, you can reverse the list with the reverse method. So now the list is in reversed order. And you can also sort your list with the sort method. Maybe this, for example, gets clearer if we use numbers here. So let's say 4, 2, 3, 1, -1, -5, 10. And if we sort this, then we see that it's now in ascending order. So note that the sort method sorts your list in place, so this changes your original list. And if you don't want to have this changed, but rather create a new list, then you can do this with the built-in sorted method. New list equals sorted, and then your original list. And note that if you print your original list again, then you see this is still the same. And if you print the new list, then you see that this is now the new sorted list. Now, some useful trick if you want to create a new list with the same elements multiple times. So for example, I want a new list with 5 zeros in it, then you can do it like this. So let's say put in a 0 and then times 5. So if we print this, then we see that we have a new list with 5 zeros. And we can easily concat two lists with the plus operator. So let's say I have another list equals to 1, 2, 3, 4, 5, and then we want a new list. So a new list equals my list plus my list 2. And if we print this, then we have a new list with both elements, with both lists inside it. So yeah, let's talk about slicing. Slicing is a very nice way to access subparts of your list with the colon. So for example, let's create a new list with some numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's create a new list and simply call it A. And then inside brackets, so A equals and then my list, and inside the brackets you specify the start index and the stop index. So let's say, for example, start index 1 and stop index 5. And if we print this, then we see we have a new list that goes from index 1 to index 5, and the last index is excluded. So it's at index 1, 2, 3, and index 4. So our list has all the numbers from 2 to 5. Now, if we don't specify a start index, then it starts all the way from the beginning. And if we don't specify a stop index, then it goes all the way to the end. And you also have an optional step index. So, and then I put in another colon and then the step index, and by default it's 1. So let's say this goes all the way from the beginning to the end with a step 1. And if I put in a step 2, then it takes every second item. And I can also specify a negative index. So this is a nice trick to reverse your list. Now let's talk about copying a list. So let's call this list original and put in some fruits in here: banana, cherry, and an apple. Now if I want to create a copy, and I simply do it by assigning it to the original one, then you have to be very careful. So if I print the copy, then I see that it's the same as our original list, but now if I modify the copy, what will happen is that it will also modify the original list. So our example, if I append a lemon, and if I print the copy and I also print the original, then we see that the original list now also has a lemon in it. And this is because with this assignment, both lists refer to the same list inside the memory. So yeah, be very careful here. And if you want to make an actual copy of your list, you can do it with the .copy method. So now if we print them, we see that the original list is still the same. And we can also do it with the list function, and as argument we use the original list. So this also makes an actual copy. And as third option we can use slicing. If I just use a colon here, so this means slicing all the way from beginning to the end. And this also makes an actual copy. Now, as a last nice little trick, I want to show you an advanced technique that is called list comprehension. So that's an elegant and fast way to create a new list from an existing list with one line. For example, if we have a list with numbers 1, 2, 3, 4, 5, 6, and we want to create a list with squared numbers, then we can do it like this. Inside brackets we say I times I for I in A, or maybe let's call this my list. And now if we print my list and print the second list, then we see that a new list got created where each element is squared. And the syntax is you have your expression and then a for in loop over your list. So note, like the same with iterating, you don't have to call this I, you can also call this X, and then also use the X here. So that's a very simple and elegant way to create a new list with some expression in one line. A tuple is a collection data type that is ordered and immutable. It is similar to a list with the main difference that a tuple cannot be changed after its creation. A tuple is often used for objects that belong together. And yeah, let's have a closer look at tuples and what you can do with them. First of all, a tuple is created with parentheses, and within these parentheses you put each element that you want separated by a comma. So for example, let's put in Max, 28 and Boston, and if we print this, we see all the elements inside our tuple. Now the parentheses are optional, so we can leave them away, and it's still a tuple. One special thing is if you just want to have one element inside your tuple, and even if you put it in parentheses and you write it like this, then this is not recognized as a tuple. So if we have a look at the type of this, then this is recognized as a string. So what you have to do then, you have to put a comma at the end. Even if it may look strange, that's the right syntax. So now it's recognized as a tuple. You can also use the built-in tuple function to create a tuple from an iterable, for example from a list. So say Max 28 Boston, and if we print this, then we also have our tuple created. Now if we want to access elements, we just do that by referring to the index. So if we say item equals my tuple, and then inside brackets we specify the index that we want, and the indices start at 0. So index 0 gives us the very first item. If we print this, then we see we have Max. Index 1 we get 28, index 2 we get Boston, and if we use an index that is too large, we get an index error, index out of range, so be careful here. We can also specify a negative index. -1 refers to the very last item, so that's Boston in this case. -2 is the second last item, and so on. Now what happens if we want to change the elements inside our tuple? Like with lists, if we write my tuple and then get the first index and assign it to a new value like Tim, and if we run this, then we get a type error. Object does not support item assignment. So this is not possible because a tuple is immutable. Now we can easily iterate over a tuple with the for in loop. So for I in my tuple, colon, and then do something. In this case, I just want to print the element. So then for each element we print it. And we don't have to call this I. We can also call it, for example, X or whatever we want. We can also easily check if an element is inside our tuple with an if-in statement. So if max in my tuple, and then we say just print yes, and otherwise we print no. And if we run this, then we get a yes, so max is in our tuple. If we check for Boston, it's also inside our tuple. If we check for Tim, then we get a no. So very easy syntax to check if something is inside our tuple. So let's talk about some other useful methods that you can do with the tuple. For example, create a tuple with some letters in it. And first of all, if we want to get the number of elements inside our tuple, we can just use the leng method, so leng of my tuple, and this returns 5, so we have 5 elements. If we want to count some elements inside our tuple, so we can use my tuple dot count, and then we count the letter P. So then we see we have 2 letter P's inside our tuple. If we check for the L, we get a 1. If we check for O, which is not inside our tuple, then we get a 0. And we can also find the first index of some specific element. So for example, my tuple dot index of P, and if we run this, then it returns the first occurrence of this element. So this is at index P. For example, if we say A, then we get index 0. If we want to get the index of L, then we get index 3. And if we check for an element that is not inside our tuple, then we again get a value error. So be careful here. We can also easily convert a tuple to a list and vice versa with the list and the tuple function. So if I say my list equals, and then I use the list function and put the tuple here, then I get a list out of it. And I can convert it back. I say my tuple 2 equals, and then the tuple function, my list. And if I print this, so then I have a tuple again. Now let's talk about slicing with tuples. So slicing is a very nice way to access subparts of your tuple with the use of the colon. So for example, let's create a tuple with some numbers in it, and let's create a tuple, and then the syntax is we use the tuple, the original tuple, and then inside brackets we specify a start and a stop index. So for example, from 2 to 5, and if we print this, then we have number 3, 4, 5. So this goes from index number 2 to index number 5, and but the last index is not included. So it only has index 2, 3, and 4 in it. So if we don't specify a start index, then it starts all the way from the beginning. And if we if we don't specify a stop index, then it goes all the way to the end. Now we can also use an optional step argument. So by default this is 1. So in this case it goes all the way from beginning to the end with a step of 1. And if we put in a 2 here, for example, then it takes every second element. And we can also use a negative step. So this is a nice little trick to reverse your tuple. Now we can let's talk about unpacking. So if we create a new tuple, like at the beginning, let's use Max, 28 and Boston. Then we can unpack it. If we write to at the left side, we write our variables, so name, age, and city, and then just say equals to my tuple. Then we get each separate element. And the city. But the number of elements that you put in here must match the elements inside our tuple. So if we just use 2 elements here, then we get a value error, too many values to unpack. But what we can do is we can unpack multiple elements with a star. So for example, if we use some numbers, so 1, 0, 0, 1, 2, 3, 4. And if we want to unpack this, so let's say I1 and then a star, and say I2 and I3 equals to my tuple. And then if we print I1, this is the very first item. If we print I3, this is the very last item. And if we print I2, then these are all the elements in between, and now converted to a list. Yeah, so one more thing that I wanted to show you is to compare a tuple and a list. And because a tuple is immutable, Python can make some internal optimizations, and thus working with a tuple can be more efficient sometimes, especially when working with large data. So let me copy this in here. In this example, we create a list and a tuple with the same elements, and then we use the sys.getSizeOf method to return the number of bytes in both of them. And if we compare them, then we see that a list is larger even though it has the same elements as the tuple. And also can be more efficient to iterate over a tuple and also to create a tuple. So if we compare, if we use the timeIt method, so there's a very nice method in the timeIt module, timeIt.timeIt, and then you can use a statement and repeat this specific number of times. So in this case it's 1 million times. 1 million times we want to create a list, and 1 million times we want to create a tuple, and then measure the time. And if we run this, then we see that it took much longer to create the list than to create the tuple. So yeah, keep that in mind, that working with tuples can be more efficient than working with lists. A dictionary is a collection data type that is unordered and mutable, It consists of a collection of key-value pairs, so each key-value pair maps the key to its associated value. And let's have a closer look at dictionaries and what we can do with them. First of all, a dictionary is created with braces, and inside these braces you put each key-value pair separated by a colon. So let's say key, name, and then colon, and then the value, max, and then you separate each item with a comma. So comma, and then let's put in another key value pair, h colon 28, comma, and another one, city colon New York. And if we print this, then we see all the key value pairs here. And we can also use the dict function to create a dictionary, and there we put all our keys as arguments. So name equals Mary, comma, age equals 27, comma, city equals Boston. And if we print this, we see that we have a second dictionary here. And note that with this function you don't have to use quotes for your keys. Now when you want to access the values, you do that by saying myDict, and then inside brackets you give it the key. So if you print the associated value for the name, then we get max. And if we want to look up the age, we get 28. And what will happen if we use a key that is not inside our dictionary? For example, check the last name. Then this will raise an exception, a key error, so be careful here. A dictionary is mutable, so you can add or change items after its creation. So when we want to add a key value pair, we simply do it like so. We say myDict, and then inside brackets give it a new key. Let's give it an email, and then the associated value, max@xyz.com. And if we print it, then we see that our dictionary now has the email key value pair here. Now if we do the same thing again and the key already exists, then it gets overridden. So let's say email is coolmax. Then we see that it still has the key email, and now with our new value. If we want to delete items, we have several options. We can use the del statement, so say del myDict, and then of the key name, and then if we print it, then we see that the name key value pair is no longer inside our dictionary. Or we can use the pop method, so we can say myDict.pop and then give it the key. Let's pop the age. So now we see that the age is no longer inside our dictionary. Or we can use the pop item method. So prior to Python 3.7, this removes an arbitrary pair, and since Python 3.7, this removes the last inserted item. So in this case it's Python 3.7, and then it removes the city. So we see the city is no longer inside our dictionary. When you want to check if a key is inside our dictionary, then there are two common ways to do that. The first one is to use an if-in statement. So we say if name in myDict, and then we can use this key. We can say print myDict name. So then max gets printed. If we say last name and want to print it, then the if statement is wrong, so this doesn't get executed, so nothing is printed here. Or you can use a try except statement, so try and then access a key, so let's say my dict name, and except print, let's just print error. So if we run this, then this statement is successful, so it can print the name. And if we want to access the last name, then this statement will raise an exception, a key error. So an exception is thrown, which is caught here. So this statement then will be executed. So if we run this, then we see that we have the error here. When you want to loop through a dictionary, you have several different ways with a for in loop. So you can say for key in my dict and then print the key. Then you can see that this loops through the dictionary and loops through all the keys. You can also say dot keys. So this will do the same thing. The keys method returns a list with all the keys inside it. You can also loop over the values. So you can say for value in my dict.values and then print the value, and then it prints the values. Or if you want to have both in one loop, you can say for key comma value in my dict.items, and then you can print the key and the value. Now when you want to copy a dictionary, you have to be careful. So the most common way to do it is like so. Let's say my dict copy equals to my dict and just assign to the original my dictionary. And now if we print this, then we see that it's the same as the original one. But now if we modify the copy, this will also modify the original one. Let's say my dict copy and add the email max@xyz.com. Now if we print the copy and the original one, then we see dictionary. And this is because with this simple assignment statement, both dictionaries now point to the same dictionary inside our memory. So be very careful if you use this expression. If you want to make an actual copy, you can use the built-in copy function. So if we use this one and print it, then we see that the original one didn't change. Or you can use the dict function, and as an argument you pass the dictionary that you want to copy. So if you use this, then we see that the original dictionary also didn't get affected. Now there's a useful method to merge two dictionaries that is called the update method. Let's create two dictionaries, and the first dictionary has a name, an age and an email, and the second dictionary also has a name and an age but no email, but then it has a city. And if we want to merge these, we can do it like this, say my dict.update and then with the second dictionary. And now if we print this, then what happened? All the existing keys or key value pairs got overwritten. So the name is now Mary, the age is now 27, the email didn't change, and the non-existing keys, the city got added. So yeah, that's a nice way to update two dictionaries. Let's talk about possible key types. So in all the examples before, I used a string as a key, but you can use any immutable type. For example, you can also use numbers as a key, or even a tuple if it only contains immutable elements. For example, we can say my dict and then key 3, and as a value give it the squared value, then key 6 and 36 and the key 9 and 81. Now let's print this. So this is also possible, but then you have to be very careful, because when you want to access a value like so, and you want to do it like with lists, and you refer to the index number, for example, say index 0, then this will raise an exception because you have the key error, 0 is not in our list. What you rather want to do is you want to use the actual key. So the key 3 is 9, and then if you print the value, then we see we get the 9. So yeah, we also can use a tuple as a key. So let's say my tuple equals 8, 7, and then create a dictionary, and as key we use the tuple, and as value we use the sum. Now if we print this, then we see we have our new tuple here, and our new dictionary here. And yeah, so tuples are also possible, but what is not possible, for example, is a list. If we use a list here and run this, then this will throw an exception, type error, unhashable type. That is because a list is mutable and can be changed after its creation, and therefore it's also not hashable and cannot be used as a key. So be careful here. A set is a collection data type that is unordered and mutable, but unlike lists or tuples, it does not allow duplicate elements. A set is created with braces, just like a dictionary, but we don't put key value pairs in it, but instead just single elements separated by a comma. For example, let's put some numbers in here and print this. Then we will see our set here. And if we put, for example, another 1 and another 2 here and print this again, then we see that only one of each element is kept, because a set does not allow duplicates. We can also use the set function and use an iterable here. For example, let's use a list here. This will also create a set. Or we can use a string here, for example, hello. And if we print this, first of all, we see that the order is arbitrary because a set is unordered and the order is not important. And we also see that there's only one L in our set. So this is a nice little trick to find out how many different characters are in your word. Now if you want to create an empty set, and you do it like this, just with the braces, then you have to be careful, because now if you have a look at the type of this, then we see that this is recognized as a dictionary. So if you want to have an empty set, you have to do it with the set method. A set is mutable, so you can change it later on. So now we can add elements, and we do this with the .add method. So let's put in some numbers here. And print this. And we can also remove elements again with the remove method. So let's remove the 3. And if we want to remove an element that is not inside our set, then this will raise a key error. So be careful here. So there's another method that's called the discard method that does the same thing. So it also removes the element, and if it does not find the element, then nothing will happen, so no error here. We can also use the clear method, of course. This will empty our set. Or we can use the pop method. So this will return an arbitrary value of our set and also removes it. So if we print this, then we see in this case it returned the 1 and also removed the 1 from our set. Now we can iterate over our set very easily with a for in loop. So for I in my set, and then do something. In this case, just print this. So this will iterate over each element and prints it. And we don't have to call this I. We can also call this, for example, X or whatever we want. Now if we want to check if an element is inside our set, we can do this with an if-in statement. So if 1 in my set, and then we print yes. So the 1 is in our set, the 2 is in our set, and if we check, for example, for the 4, then nothing gets printed. Now let's talk about union and intersection. And for this case, first of all, let's create 3 different sets. One with odd numbers, one with even numbers, and one with prime numbers. And now we can calculate the union. So the union combines elements from 2 sets without duplication. So let's calculate the union of odds, and we do this with dot union and then as an argument the second set, so evens, and print this. Then we see that now we have all the numbers from 0 to 9. So the union will combine elements from 2 sets without duplication. We can also calculate the intersection of 2 sets. So the intersection will only take elements that are found in both sets. So if we say the intersection equals odds dot intersection evens, and if we print this, then we will get an empty set because odds and evens don't have the same elements. Now if we calculate the intersection of odds and primes, we will get all the prime numbers that are also odd, so 3, 5, 7. If we calculate the intersection of evens and primes, then we will get back only the even prime numbers. So in this case, only the 2. Now we can also calculate the difference of 2 sets. So let's create 2 different sets again. Set A with numbers from 1 to 9 and set B with 1, 2, 3, 10, 11, 12. Now the difference will return a set with all elements from the first set that are not in the second set. So let's call it diff equals set A dot difference set B, and print this. Then we see that we will get back the numbers from 4 to 9 because it takes the elements from our first set but not the ones that are also in the second set, so only from 4 to 9. So if we do it the other way around, set B dot difference set A, then it will take 10, 11, 12, but not these three numbers because they are also here. So then there's a second difference method that's called the symmetric difference method. So the symmetric difference method will return a set with all the elements from set A and set B, but not the elements that are in both sets. So again, it takes 4, 5, 6, 7, 8, 9 from set A and 10, 11, 12 from set B, but not 1, 2, and 3 because they are in both sets. So if I use set A, symmetric difference set B, then this is the same thing. Now, union and intersection and the difference method that I just showed you, they will not modify the original sets. They always will return a new set, but we can also modify our sets in place. So, for example, we can say set A dot update set B, and now print our set A. Then we will see that this updates the set by adding the elements that are found in another set. So without duplication again, so it does not add 1, 2, and 3 again, but it adds 10, 11, and 12. There's also a intersection update method. So set A dot intersection update set B, and what this does, it updates the set by keeping only the elements found in both sets. So only 1, 2, and 3 are found in both sets. So only these numbers remain in our set. Then there's also the difference update method. So set A, difference update set B. And if we print this, we will see the numbers from 4 to 9 because difference update, it updates the set by removing elements found in another set. So it also finds 1, 2, and 3 in the set B, so it removes these numbers from our set A. And then there's the symmetric difference update. So this updates the set by only keeping the elements found in set A and in set B, but not the elements that are found in both. So 1, 2, and 3 are found in both sets, so these are not taken, but then it takes all the remaining elements from both sets. Yeah, you probably have to play around with them yourselves a little bit to make it clearer. And yeah, let's also talk about subset, superset, and disjoint methods. So, for example, let's make them a little bit smaller. You can calculate if set A is a subset of set B, and if we print this, then this will return false, because subset means that all the elements of our first set are also in our second set. So if we use it the other way around, set B is a subset of set A, then this will return true because 1, 2, and 3 are also in the second set. And the opposite is called the superset method. So is superset, And in this case, it returns false because a superset returns true if the first set contains all the numbers or all the elements from the second set. So set B does not contain 5, 4, 6, so it's not a superset, but set A is a superset of set B because it contains 1, 2, and 3. And we can calculate if two sets are disjoint. So disjoint returns true if both sets have a null intersection, so no same elements. So set A is disjoint set B, and if we print this, this will return false because they have same elements. And if we create, for example, a set C and put 7, 8 in here and check set A is disjoint with set B, then this will give us true. Now let's briefly talk about copying two sets. If you have watched the previous episodes about lists, for example, then you already know this. You have to be careful when you want to copy two sets and only do this with a simple assignment. So let's say let set B equals to set A. First of all, if we print this, then we see that we have a copy, but now if we modify the copy, let's say set B at 7, and if we print the copy and also print the original one, then we see that also the original one changed, because with this simple assignment both point to the same set. So be careful here. You only copy the reference. Now if you want to make an actual copy, you have to use the .copy method. So if you run this again, then we see that the original set didn't change. Or you can also use the set method and use the first set as an argument. This will also make an actual copy. Now as a last thing, I want to show you the frozen set. The frozen set is also a collection data type, and this is just an immutable version of a normal set. So you create this with the frozen set method, and as an argument you can also put an iterable here, for example a list, and let's print this. Then we see our frozen set here. So with a frozen set you cannot change it after its creation. So if I try to do a dot add 2, this will give us an error. Or I can also say try a remove 1. This will also give us an error, or any of the update methods I showed you, they also don't work. But for example, union, intersection, and difference method, they will work. A string is an ordered and immutable collection data type that is used for text representation, and it is one of the most used data types in Python. So I hope that at the end of the session you'll feel comfortable working with them. So let's start. First of all, a string is created with either single or double quotes. So you can use double quotes and then put your letters in here. So let's say hello world, and now we can print this. And then we see our string here. Or you can use single quotes. This is probably more common. The only thing you have to be careful is if you have another single quote inside this. So if you have, for example, I am a programmer. Now if you try to run this, then this will get a syntax error. So what you can do is you can either use an escaping backslash here, so this is valid, or you can put your single quote inside double quotes. So this is again a valid string. You may also sometimes see triple quotes. So this is typically used for multi-line strings. So now I can go in another line. And this is also used for documentation inside your code. So now if we run this, we see that our string goes over multiple lines. Now you may also sometimes see an escaping backslash like so, and this just says that the string should continue in another line, but it should not create a new line here. So now if we run this, then we see we have our one line hello world string. Now if you want to access characters or substrings, it's the same like with lists. You access it with, inside brackets. So let's say char equal, or let's create the string first, sorry, my string equals hello world. And then you can say char equals and then my string, and then in brackets you put the index you want. So if you want the very first character, you have to use index 0. So we can print this. So this is the H, and if we use index 1, we get the E, and so on. We can also use a negative index, so -1 is the very last character, -2 the second last, and so on. But what we cannot do, for example, is we cannot access a character and change it. So if I want to change the first character to a lower H, if I try to run this now, this will get a type error. String object does not support item assignment, and this is because strings are immutable, so they cannot be changed. So be aware of that. Now we can also access a whole substring with slicing.